Hello everyone, in this video we will discuss how to run SWAT CUP for calibration and validation. So this is my daily data starting from 1st of January 2000 and it is going toward 2018, 31st of December 2018. So it is just a reference data, you can use your data instead of this one. Okay, then how to prepare the data for SWAT CUP. This is my main task here. So as we all know, most of the time methodological modeling is on monthly basis. Most of the people run methodological models such as SWAT, QSWAT and others on monthly basis. So this data is on daily basis. We need to convert this data to monthly basis if we are working with the model methodological model on monthly basis. Similarly, if we are just using daily data, model is on setup on daily basis, so we need to use on daily basis. Actually, in my case, I have run the SWAT CUP, my SWAT software on monthly basis, so I will first convert it to monthly data set. So if how to convert it daily data to monthly data, just follow me step by step. So just select all this and go to insert tab, and under pivot table you will find in top left side, click on pivot table and click on OK. So here you will click on date and on the aggregate, the second column, whichever you have, and just uncheck this quarters. Under the values tab you can see sum of aggregate. So check right click here, left click here and click on values, value field setting, and the value field setting you have to check average. So we are just going to use average values, not the sum. So it is converted to 2000 and under 2000 you can just left click here, then right click and go to group. So under group setting you have to uncheck quarters. So click on OK. You will see the data is starting from 2000 and on monthly basis. But here is the main problem. You can just copy and paste all these annual years one by one, or you can just use again right click and go to subtotal years. Just uncheck it. So if you will uncheck it, it will be removed and your data will be arranged on monthly basis. So just click up that column and copy, Control C. After copying, go to another sheet and paste it as it is. So here you can see your some values, some column are blank, some cells are blank actually. So how to remove these blanks? Just click select the table, entire column, and go on to data and again into filter. So again, when you check filter, you will see a down arrow here. Just click down arrow, and under the down arrow you can just go to the bottom and uncheck blanks. So in this way all your blanks value will be removed. Again you have to just copy this all, Control Shift down arrow, and you will copy, Control C and go to next sheet. So here you can use paste. So you can see your data is already pasted here. Okay, but here there is no date column. We will just write as date. So it is 1st of January. Starting month is 1st of January 2000. January. You can write as January 9, 2000, because it is our starting month. Okay, then we will just double click here and everything will be done. So you can see it is going to a downward and it is January, December 18. One extra column is there, you can just remove it. Okay, so just delete the last one because we are just working on December 18. Okay, Now still there is something we have to use other things. Let me show you. We have to add some you can see here a dash. Put a dash here and extend it to the end. Okay, so let's begin. Now we have to add ID. So ID, you can type ID, and from here you can start with 1, 2 and up to. So okay, and after ID we have to add months and year. So just it's months. Okay, so first one should be the first month. So just use equal sign and type months. So just check first one and press click the date column and click on enter. Okay, in this way your all the months will be extracted from your date column. So just double click and it will be arranged. Okay, then we have to add years. So again similar method is equal sign year the first one and check the date column, enter. So it is year 2000. Again just double click here. So all the year will be extracted, months, years and ID and this dash symbol. So now we have to merge all these. One more thing, we have to write flow out. Flow out. Flow out and okay, just type this one and double click. So you can see flow out till end. Now you can see this flow out till end. Okay, now the next one is to join all these. So for joining we will use is equal sign con concatenate the first one. Double click and we have to merge all these in a proper way. Let's see, float comma month and year. Okay, so float 1 2000 and close the bracket and press enter. So you can see, oh, there is an error. We can go again because we have to add a dash symbol after the month 2. So I have missed that. Just again repeat float and month and again we have to use this one dash comma and that. So now it is fine. Let's see. Yes, it is looking great. Flow out 1 2000 and just need to double click and go to end. Okay, so it is our flow out, and similarly here is our flows. Copy it and paste it in front of that. Okay, so in this way you can prepare your data for calibration, and in the same way you can prepare your data for validation. Okay, just you need to I will show for the steps after the in the SWAT CUP. Let's begin with SWAT Cup. Let's open SWAT Cup app and open it. Let's see. Okay, SWAT Cup is opened and we need to click here to start new one. Click on next, and it is asking for text in out location. So it will be located where you have run your SWAT or SWAT model. So I am just going to give it my text in our location and just click on browse. It will move toward your directories. So my project is located under my data. Let's find new folder 3 here, and scenarios, and the 0-year skip, and here text and out. So in your working directory in which you have run your SWAT Cup, or sorry, SWAT or QSWAT model, there is a folder of scenarios. Under scenario tab you will find the default values, or you have your own, maybe another. So under scenarios, go to your folder, default folder, and click on text input and open it. So I have given it my text input directory. Just click on next. So it is asking for SWAT version. So let's see, my SWAT was returned 12. So maybe your SWAT may vary depending upon your SWAT. You have to give it your SWAT version. So processor, mine is 64 bits. So next, and choose a project. In the project type you have to choose SUFI 2 and click on next. So project name, where you in the new project name you are working on SWAT Cup project name. So I'm just giving it to my name, Harun. You can see video. Okay, so project location, just browse where you want to save. This is the name you want to give and the location you want, where you want to save. So I'm just going to save it in documents. Okay, and finish. So now it will start copying from some files from your text input files from your project to SWAT Cup. So it will take some time, a little. So files have been copied and some other files are also copying. I have to wait. Okay, after the copying will be completed, you will see your project name here. So go to calibration inputs. So under calibration input you have to find parameter information.text. So double click. Okay, we will find some parameters here, 4 parameters. So these are some basic parameters. These are not enough. It is only the game of some parameters actually. So we have to use different parameters depending upon the characteristics of our watershed. So in case of Gilgit River watershed, so I will use 22 parameters. I will discuss here one by one. So first cn2, its minimum value should be minus 0.4. so you can use the same values as I am providing for your version 2 if it is on mountainous or some snowy version. So for alpha BF it is from starting from 0 to 0.6. I have got these values after sensitivity analysis. I am not going to discuss sensitivity analysis here. I am just going to add some values. So I hope these values will work for your version 2. Okay, and then GW MP1, its value should be 0 till 2. It's okay. So we have to add some other parameters. Click here, add new parameter, add a new parameter. Okay, so in add a new parameter you can find many. So go to some groundwater parameters, GW. So in GW you can find I have already uploaded some groundwater parameters. Let's see, it's GWMQ and GWDaily and all are groundwater parameters, these three. So we have to add some other GW parameters such as GW revap and recharge DP. So GW revap is here. Okay, and for GW revap its value should be 0 till 0.2. okay, 0 to 0.2. okay, so it is looking as red. So if you have to change the number of parameters from here, so it is green. So we will use 22 parameters here. So we have to add some other parameters. So again GW, so it is some time taking work. So you have to select one by one. So again I'm going to use recharge, deep recharge. Okay, so again 6th, so recharge deep value should be from 0 to 1. okay, and again one new parameter, it should be RTE parameters. So it is CHN2 and similarly CHK2. okay, so these values, their values should be from 0 to 0.3 and 5 to 100. These values I got using some uncertainty analysis. So we have to, I'm just repeating those steps and adding those values which I started, initial values. So again RTE, it is some alpha bank, and okay, and its value should be 0 to 1. So again a new parameter, some SWL parameters. We have to find this one, sol AWC, available water content. So we have to find this one. okay, so again a new parameter, sol parameter, sol AWC, sol K here, and similarly add a new parameter of sol N, maybe we have Mr. sol BD. Bulk density is also very important, so I'm just going to use sol BD. Here is sol, again need to check, and where is sol BD, this one. okay, So we did not provide any values here. We have to add values. So its value should be minus 0.2 to 0.4. Okay, and the sol k value should be minus 0.8 to plus 0.8, and similarly sol bd, soluble density, its value should be minus 0.5 to 0.6. Okay, so we have to use again new parameter. So here some basin parameter, sftmp, and similarly smtmp, and smfmx, and it is fast or no, so smfmn. So these values, their values should be minus 5 to plus 5, and similarly minus 5 to plus 5, and here fmx, it should be 0 to 20, similarly here 0 to 20. Okay, still some parameters are left. Again add parameter, basin, in basin we have to go to find TAMP. Okay, so TAMP values should be SMFMN value should be 0 to 20, and TAMP values should be 0 to 1. Okay, we can just increase and down, add a new parameter. I can find some subbasin parameters, SUB and subbasin plabs, and okay, similarly again subbasin and plab. So plabs, and I think I have repeated plabs again, so just here and can delete it. Okay, again add a parameter subbasin, and you can find plabs. Okay, and for plabs it should be minus 20 to plus 20, and for plabs it should be minus 300. Okay, so now again another parameter, XRU, ESU, 0 to 1, and again add a new parameter. So basin, snow max, and basin, snow minimum. Okay, so I think it is repeated again. So read this, snow maximum and snow 50 cover. Okay, so snow maximum it should be 0 to 400, and for snow 50 cover it should be 0.1 to 0.6. Okay, so our 22 parameter have been selected. So number of simulation, we have to use 1000 simulation for each step. So first step done under SUFI tool. starting simulation 1 and the ending simulation should be 1000. Okay, and file CIO. So number of years simulated, overall 23 numbers years I am working with. You need to change this number of years according to your distribution. So I am using 23. My total years are 23 years from 1995 to 2017, but I have to use 12 years for my calibration and remaining 11 years for my validation. So I am just replacing it with the 12. Okay, my starting year is 1995 and beginning year semester 1 and everything will be fine. Okay, so go to the next step. SWAT values. So just keep it as it is. No observation. So click on RCH and observe RCH. So you have to delete all this data from here to end, because this data is already default data sets and we have to provide our. So number of observed variable should be 1 because that is only flow. Okay, and so here it is asking for flow out -1. So here you have to provide the last flow out of your last submission. So I think you know the number of submission in your SWAT, SWAT or QSWAT project. So in my case these are 27. Yes, so just change it to 27. And for calibration I am using for 12 years. So 12 years have 144 months. So just type 144, and now here we have to provide our observed data sets. So we have already prepared. I already showed you. So here, let's see. So from here we can pick our data sets. First one is ID and some of the other one, and at the end is our average flows. So we have to copy 144 readings here. Okay, from till 144. Control and C, copy it and just go to SWAT CUP and paste it. So job is already done. So data is already pasted. Okay, so now go to extraction, variable file.rch, delete all these and just add 27, the last submission value at the end. So if you do extract.rch, so number of variable to get 1 and it is 7th column is for flow, so delete the other one. And total number of submission, how many submission do you have in your project? It is 27. Okay, and so number of reaches to submission to get for reaches, this one 1 and which one 27, because you are willing to get the flows of last submission and the outlet point. So 1 and 27, and number of reaches submission to get for the second variable. So we do not have any second variable, just delete it. Okay, so beginning year of your simulation, it should be the starting year of your project. So it is 1995 till 2006. So for my calibration purposes it is 2006. And time step, if you are using daily data, so you have to place 1 for monthly, 2 and for annual 3. So it is already 2, I am using monthly data sets. Okay, again objective function. So click on objective function observe.txt. Number of observed variable you have to one, and objective function. So ns, okay, 5 is fine. You just have to change the float. It is float 27, and again you can see there are 144 data points, but we have 144 here. It was 141. So change this one and delete the all others. Okay, so these are the default data sets by SWAT CUP, so we do not need to use that. We have to place here our data set. We can again copy, as I already copied it, and paste it just here. Okay, so variable file name, it doesn't matter which the variable file name you are going to use. Again, I'm just writing flow 27. Okay, so no observation, we do not need to change this, but again number of variables to get 1, similarly 7, have to delete all other, and total number of submission in the project 27. We have to delete these all, only R flow is the requirement. So number of submission to get for the first variable 1, because we have only to worry about our one submission, last one. So second variable is not required, and third variable is also not for concern, just delete it. Numbers to get for second variable, we do not need it. Okay, beginning year I already written, it's 1995, depending upon your project setup, and at the ending year of 2006, and that is okay. So everything is fine. So extract reach, no, extract HRU. We have again make similar changes, such as 1 variable column 7. 7 is actually the column of flow, and we have to change the name and give it as R flow, as we give extract RCH R flow. Copy it, and control V. Okay, so variable name is done. Total number of submission 7. Number of HRU, so I have 38 HRU. So but one actually I'm found one HRU. Wait, the last one, because it is in the last submission. So for second variable and third variable, we do not need anything. We have to delete this, and again we have to change the beginning year of 1995 and ending year is 2006. Okay, similarly have to go for other next one. Okay, so everything is done. Then we check it, 1000, and the values 1000, and 12 years 1995. Okay, and again absolute values for SWAT. Okay, these are not our concern. So flow 144 and values. Okay, so I think everything is fine. Just go and click on calculate. So here you have verification of SUFI 2. Okay. So in this way your calibration will be started, and hopefully you will get accurate results. So this process already selected, I have already run this. So let me show you my results. If you did not get any results in an accurate range, you have to just replace the variables. So let me show you how. Just click on close and okay, terminating it because I have already run that one. Okay, so I am just going to show you my results. So this is my actual work, calibration. Okay, under iteration stream, I have gone over my calibration, last one, calibration outputs. So calibration outputs, we have 95 pp plot. So this is the plot of my the result of my calibration, and you can see the summary also here. Here is the summary. I got RCK 0.89 and NAS efficiency 0.88. Similarly for validation, I got the outputs summary. So for my validation it is 0.82 and R square and 0.81 the NS, and 95 ppg for my validation. So it's looking like this one. I hope this video will help you in the calibration work for your own watershed. So hopefully it will help you. And if this video is very helpful for you, then please subscribe to my channel, share it with your friends. Thanks a lot.